So this problem is asking for the change in the stopping distance as speed changes. So we're looking for a change in y, which we're going to find by using the increment formula, which is a change in y. To do this, we're going to plug in our x's in the equation, like in this problem, the 27 and the 28. First, we're going to plug in our second x, which is our 28, and then we're going to subtract that by our first x, which is the 27. To separate our different functions, we recommend to use brackets to avoid confusions. After we subtract our both functions with a calculator, we get that our first answer is 462 subtracted by 432, leaving us with 30 miles per hour. Now they're asking us for the percentage of this change, and we're going to do so by using the formula f of x2 divided by f of x1 multiplied by 100, giving us 462, which is our f of x2, divided by 432, which is our f of x1, giving us 1.069, and multiplied by 100, it gives us 106.94% of incrementation. Now, it is asking us to look for the approximation of the change in the stopping distance as speed changes. So we're going to use the formula of approximation, that is dy is equal to f prime of x times dx. So first we're going to find the derivative of the function, that is 2.5 plus x. And to write the complete function, we're going to write dy is equal to 2.5 plus x times dx. But to find dx, we're going to use this formula, that is dx is equal to the second x, that is 28, minus our first x, that is 27, that is equal to 1. So we're going to write the complete formula now. dy is equal to 2.5 plus the number 1x, that is 27, times our dx, that is 1. And that leaves us with 29.5. So dy is equal to 29.5. We have a different question in the same problem that is asking for the percent change, and we're going to do this by using the formula dy over f of x1 times 100. So our dy is 29.5 that we already got, divided by 432 that we already got, that is our x1, times 100, and that is 6.8%. And that is our percent change. The next question is asking, what is the percent telling about the situation? The percent we got in the past problem was 6.8%. We got this from this function, where we have 27 and 28 as our x's. This percent represents the percent of change in this function between this mile to this mile. So it incremented the speed 6.8%. This problem is asking us to antiderivate it, and to do so we have to do it by substitution, since we have two functions and the powers have a difference of 1. If they didn't, then we have had to solve it another way. Our first step was to identify our u, which is the most complex one. In this case, it is the 2 minus square root of x. Then we have to solve for dx by derivating our u, which was negative 1/2 x to the power of negative 1/2 dx. Then our dx would be equal to du over negative 1/2 x to the 1/2 power. Next step is to simplify. So we're going to rewrite it for us to be able to simplify it. we cross out the ones we simplify, and then we start integrating. So it will be negative 12u8 over 8 plus c, because we add 1 to the exponent, which was 7 plus 1, 8, plus c, and we write our final answer. Always remember to add the c at the end. So it will be negative 3 times 2 minus square root of x to the 8th power divided by 2 plus c, and this is our final answer.